Welcome back. This is Tony Burbsky. Gonna cruise through section 11.2, one of my personal favorites. Um, it's formula driven, um, and it's also about triangles that are not right triangles. Even though it works with right triangles, nobody would ever use this because you have SOHCAHTOA and CHOA-SHIKAO. So, anyway, let's get after it. I'm gonna give you some formulas. A squared equals b squared plus c squared minus 2bc cosine capital A. And similarly, b squared equals a squared plus c squared minus 2ac cosine B. And c squared equals a squared plus b squared minus 2ab cosine C. Now, you should be able to look right here and pitch it over. Hold on, let's go the other way. Let's pitch this over here, and let's pitch over the 2 BC cosine A. So you should be able to see this in one stroke. B squared plus C squared minus A squared. And over on the other side is a 2BC cosine A. And let's divide by 2BC. And in addition, let's do inverse cosine. B squared plus C squared minus A squared all over 2BC. So, let's write down two more. B, similarly, C, similarly, divided by 2, divided by 2. If it's a b here, it's a minus b squared here, so it's an a squared plus c squared, and you see the b and c, therefore the a and c go there. If there's a c here, it's a minus c squared, and therefore an a squared plus b squared, and you see these two, ab. Those are the 6 formulas that allow me to cross this section. What I do is I actually preload them on my calculator. You don't have to do it this way, but I try. So, this formula, I actually type in A. I'm going to take the square root of both sides. So A, let me see if I do this, light this up. So you go down to, okay, y0. So there's 1, 2, 3, 4, 5, 6. So from y5 down, you're going to fill these up. Square root alpha b squared plus alpha c squared minus 2 alpha b alpha c cosine alpha a. Scooch. Square root alpha a squared plus alpha c squared minus 2 alpha a alpha c cosine alpha b. Scooch. Square root alpha a squared plus alpha b squared minus 2 alpha a alpha b cosine alpha c. Scooch. And then I type in the bottom 3. Inverse cosine, parenthesis for the numerator, alpha b squared plus alpha c squared minus alpha a squared, parenthesis for the numerator, divided by the parenthesis for the denominator, 2 alpha b alpha c, parenthesis parenthesis. And again, inverse cos, parenthesis for the numerator, alpha A squared plus alpha C squared minus alpha B squared, parenthesis for the numerator. Ooh! Squared. Ouch. I hate it when they have to do this. Delete, 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 delete. Squared. Sorry. I am struggling. The B squared. Oh, okay, let's just delete it all. I don't know what's wrong. Lost focus here. Give you a chance to get caught up. Minus alpha B squared. What? Oh, I just can't. Oh, sorry. My eyes are going. Don't get old. Um, Squared. Oh. Okay, I got this. Okay, alpha B squared, parenthesis for the numerator, divided by parenthesis 2 alpha A alpha C, oops, second quit, y equals, I'm struggling. I lost so, whoa, oh, okay, here we go. Divided by 2 AC parenthesis, oh, inverse cosine. Let's see how I do this time. Parenthesis for the numerator. Alpha A squared plus alpha B squared minus alpha C squared, parenthesis, divided by parenthesis 2 alpha A alpha B parenthesis. Whew! Get the heck out. All right, loaded up my 6. So let's do some law of cosines. Now, law of cosines is side angle side and side side side. So here we go. If I give you a side to be 11 and an angle to be 98 degrees and give you a 13, I got a side, I got an angle, I got a side. Law of cosines works. So let's call this A. Therefore, this is little a. Therefore, this is, we call this B, making this big B. Forcing this to be little c, and this to be C. So, got to be careful. So what we're looking for is this side right here, A, which is also known on my calculator as Y5. So you just would plug your formula, you would plug it in, mathematically, the answer is A is the square root of B squared plus C squared minus 2 times 11 times 13 cosine 98. But I have that typed in my calculator. So what I'm going to do is I'm going to go 98 stow alpha A, 11 stow alpha B, and 13 stow alpha C. And then what you're going to do is you're going to look in your table at Y5. And you see how Y5 is 22.8898? That's what you get. Now, if you want to know more decimals, because we're limited here, I think you can go to what I do is I go y-vars function Y5. I think I can just hit anything. Yeah, just hit Y5. And it's really 8979570.7. case you need more decimals. Or just do it by hand. Now, I would like little b. Now, little b, there's y5, y6, y7, y8, y9, and y0. Little a, little b, little c, a, b, c. So if you want little b, you need y6. So you got to type in the right stuff. So if you want little b, oh, hold it, I already have little b. I have little c. I want to find the angles. So sorry about that. We're given angle A, we want to find angles B and C. So here you go. If you want to find angle C, let's say C is inverse cosine, it's A squared, which is, well, we know A squared, we just found it, plus B squared minus C B squared it's A squared plus B squared minus B squared is 11. B is 11. Minus 13 squared over 2A11. You can type that in. And you just found A, so make sure you use enough decimals, like all of those. So what do you say we actually stow that number to alpha A, the last number? Now, we want to use, so we stored that, and we're going to find this angle right here. That was little b, so 11 stow b, and maybe it's already stowed, but 13 stow alpha c. Now, since these inverse cosine formulas just have the a's, b's, and c's, and then when you flip flop them all around, what I'm going to get is all the angles. I'm not going to just get angle C. I'm going to get angle A, angle B, and angle C. But I already know angle A is at 98, so I'm going to get angle B and angle C. Because if you look at the table, whoa. Oh, mode. Degrees. Look at the table. Angle A is there we go. Angle B is 15.98. Angle C is 18.998. Once again, you could do it all by hand, but remember, angle B inverse cosine of minus b squared, a squared plus 13 squared over 2a13, you will get those values. So what I'm using is my calculator to crank them out. What I'm trying to say is, if you know all three sides, you know all three angles, because the calculator under y8, y9, and y10, y sub 0, will be my angles. So bottom line, I don't do a lot of pencil pushing in this section. So let's go for another one. A little side, side, side. A little 5, a little 6, a little 9. Not even close to scale, it doesn't matter, because if I call this A and I call this B and I call this C, I'm going to find the corresponding angles ABC. So this is the easiest problem we have, because 5 stow alpha A, 6 stow alpha B, 9 stow alpha C, and then in Y0, Y9, Y8, it's angles A, B, and C. Or use those formulas I gave you for A, B, and C, and just plug in the numbers. But bottom line, just scooch, 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 scooch. Okay, so A is 31.586, 38.942, and 109.47. Once again, if you go vars, y vars function 8, vars, y vars function 9, and vars, y vars function 0, you get the decimal expansion of those three. So, and since they're angles, if you want to go second angle 4 and convert the last one to degrees, minutes, seconds, there you go. Should be able to crush just about any problem. The beauty of a lot of cosines is there's always one triangle, or there's no triangle. There's no two triangle case, meaning I love side angle side, and I love side side side. Now, for more fun, there's these cool formulas for finding area. One of them is S. It's called Heron. It's a lot of fun, actually. Let S be 1/2 A plus B plus C. So if I give you the three sides, and you use this area formula, it's S, S minus A, S minus B, S minus C. It'll give you the area. So like on that last problem, 5, 6, 12, 5, 12, 5, 6, 9, A, B, C. Let's let S be 1/2. 5 plus 6 plus 9 equals 11, and 9 is 20, therefore S is 10. The area is the square root of 10, 10 minus 5, 10 minus 6, 10 minus 9, square root of 200, which is square root of 100, square root of 2, which is 10 radical 2, which is stinking awesome. I love the formula. Like, this is stuff that you don't get to do every day. It's called Heron's formula. Feels like a trick. Can I do like that on my calculator? Sure, I can probably, I already have A, B, and C stored. So I can go 0.5 alpha A plus alpha B plus alpha C, stow alpha S. Then I can do the square root of alpha S times, here I'll go just parenthesis, alpha S minus alpha A, alpha S minus alpha B, alpha S minus alpha C, scooch, enter, and get 14.12, which is 10 times radical 2. Sure enough, it works. Can I drive it into perhaps a square root of alpha S, alpha alpha S, sorry, alpha S minus alpha A, alpha S minus alpha B, alpha S minus alpha C, scooch, and then just look in Y4. Yep, 14.142. So you can cheat it out, but you're starting to run out of places. It's pretty crazy. All right, so there's more. There's more area formulas. If you know your side, let's say it's 27.3, and you got 24 and 40 minutes. And that is dumb. So back her up. The book, trying to work a problem out of there, it's kind of dumb. So let's do this. 7, 121, 9. You got a side angle side. If you call this A, this is A, and let's call this angle B, this little b. Let's call this obviously C, therefore this is C. If you got side angle side, you're allowed to use this formula, 1/2 AC sine B. And there's two more, 1/2 AB sine C, and 1/2 BC sine A. And this is area. So just remember, if you got a side angle side, you should go 1/2 of the two sides, sine of the angle, boom, area. So what I'm saying is area equals 1/2, 7 times 9, sine 121. Second quit, 63 divided by 2 times sine. That area is 27.0000076,997. Boom. That's area. So those formulas are awesome. Just remember 1/2, two sides, sine of the angle, and it has to be side angle side, which is my favorite thing. I love side angle side because that means I get to use law of cosines. Law of cosine is you need to memorize 6 formulas or get them plugged into your calculator. Law of cosines means there's only one answer or there's no answers. Law of sines is the hard one. Law of sines, when they give you one angle and two sides, sometimes you got to reason if there's 2 triangles, 1 triangle, or no triangles. So remember, a lot of people hate law of cosines. That is wrong. Law of cosines is the easy one. It's just 6 formulas. You're just plugging in numbers. Plus, in addition, you got some really kick-butt area formulas that work for side, 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 and side angle side. So, law of cosines, side, 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 angle, side. Law of sines, you need a pair. And if you got an angle, side, side, that's not good. That's a hard problem. After all, it does spell ASS. It's a pain in you know what, not your angle side, side. So, anyway, it's supposed to be humorous. I don't know if I should work another problem or not. What the heck. I'll work a problem out of the reading just to show you. Like, this is 52. It's a really nice, like, there's a beam and it's 90 feet, and this is 45 feet, and this is 60 feet, and there's some weight, and of course it's very applied. But bottom line, I got side, side, side. They're going to want to know the angles. I'm going to kill this thing as soon as I label them. If I call this A, this is big A. If I call this B, this is big B. And if therefore this is C, and I call this big C, and then I go second quit, I'm clearing it, and I go 45, stow alpha A, 60, stow alpha B, 90, stow alpha C, and I look in my table, y8, y9, y10. So y10 is C, 117.28. Y9 is B, 36.336. Y8 is A, 26.384. And once again, second quit, go home, y-vars function 8 is A, y-vars function 9 is B, and y-vars function 0 is C. There is the decimal expansion. These problems are fast. This is a very good assignment if you master the calculator. If you typed everything in correctly, just like I did, you will be awesome. All right, sorry, that's it. That's all I got. It's only that hard. Spent 26 minutes, wasted an extra 4 minutes at the end there. Great section. See you later. Oh, yeah. Once again, call me, 720-985-1986. Better yet, text me, tell me who you are and what you need, and then when I get time, I'll call you back. See you later. This is Verbsky, over and out.